specific set of vocabulary that you absolutely have to know. And not just know the words, but you have to understand what they mean and how to distinguish between them. The words we use in physics are very precise. And if you don't understand the nuances that separate one thing from another, it can be very hard to then solve problems. So we're going to run through a few important factors like that now. So first thing, magnitude is just a fancy word for size. So the magnitude of acceleration, the magnitude of your electric field, the magnitude of your force, anything, it's just how big it is. So it's just a value. Negligible is the meaning it's so small that you could ignore it. That comes up mostly when we're talking about air resistance, right? When we're doing air resistance, we're assuming it's negligible. Same thing with friction half the time. We're just going to assume it's negligible, which means it's so small, don't worry about it. When we talk about instantaneous, we mean right now, like right now. No, now, right? And we're just talking about that very instant. It's actually not a possible thing to measure. You always have an interval. You always have some change in time, but as if that time span is small enough, we can call that instantaneous. When one thing is inside of another, they must have the same velocity. So if you're standing inside of a moving train or a moving plane, or you're sitting in a car, you have the speed of that object. If you're walking and you're carrying a book, the book has the same velocity as you do. Okay, there are only 4 types of motion that we are going to talk about at this level. At rest, moving at constant speed with increasing speed or decreasing speed. That's it. So when you're asked about what type of motion, those are your 4 choices. 4 choices. Don't make up any others, and don't say anything else. It's at rest, constant, increasing, or decreasing. All right, let's distinguish between position, distance, and displacement. Position is where you are. It's a point on a coordinate system. You have to know where 0 is. We make up where 0 is. There is no great, Cartesian coordinate system in the sky. We say 0 is at the edge of the desk, or 0 is the floor, or 0 is the surface of the table. Whatever, we make that up. Distance is the amount of space between 2 things, or how much you've actually traveled. So it's not an easy thing to define, but it's usually the change from one position to another. But it doesn't have any sign. So if you travel from one position to another and back, you've covered that whole distance. So every step you've taken has to be counted. For position, we generally use the symbols X or Y. It's a position in meters relative to that 0 value. Distance is D, but I've also seen S, R, X, delta Y, all of those still mean distance. There's a lot of different symbols for it. And the position and the units are still in meters. We always use the metric system. Displacement is, again, related to those, but that is the change in position. Okay? It's a vector quantity, which means that it is relative to the initial position. So if you go, which means that if you move away from a point and then back towards it, it's how far you end up from the original position that matters. So the symbols are delta D, delta X, delta Y, delta R, delta S. Any of those means change in position. Delta means change, right? So it's always final minus initial. So final position minus initial position, like that. Okay. Units again are in meters. So this is a graphic that shows here's your distance, but your displacement is always a straight line between the beginning and the end. So speed versus velocity. Speed is how fast you're moving, right? It's the rate at which you cover distance. It's the distance total over the time elapsed, right? And the symbol is V. The units in the metric system are meters per second. Velocity is very similar. It's speed in a particular direction. However, it's calculated a little differently because it's more about the displacement over time. But you'll notice that the symbol is the same, and the units, well, these units are wrong. They should say meters per second. So, but the units and the symbol are exactly the same for speed and for velocity. We do not use S for speed, just so you know. That's distance, actually. And so we'll do some practice with that. But the definition is the rate at which object changes position. So what does it mean to have constant speed or velocity? It means it's unchanging. Right? It's always the same. It's 50 miles per hour, 50 miles per hour, 50 miles per hour, or 3, 3, 3, 3. It's always the same. You have no acceleration. So let's distinguish between instantaneous and average velocity. So an instantaneous velocity is a really small time, and therefore generally a really small displacement. So it's your displacement over time, where the time period is very small. Your average velocity is just your total distance over your total time, or your total displacement over your total time. And that could be very, very large. So it might vary, right? The actual velocity may vary from one position to another, but you're getting an average of all those velocities. It could also just be like, hey, for this amount of time I have this speed, and for this amount of time I have this speed, and average those together. So it could be done either way. Okay, we have to talk about signs. Signs in physics tell you direction only. So I decide which way is positive, or generally we just use the Cartesian coordinate system. Up and to the right are positive, and down and to the left are negative. And the only thing that positive and negative means is direction. So think about it. You can't go slower than not moving. So if I said you're going -5 miles per hour, well, you're not going less than 0. It just means you're going 5 miles per hour to the left or west. So the rate at which your velocity is changing is called acceleration. The symbol is lowercase a, and the units are meters per second squared. Acceleration can be either your speed is changing, or your velocity is changing, or you're changing direction. Change in speed or change in direction. Either one or both. Okay, so it's how fast that's occurring. So what does it actually mean to have an acceleration? So if you're saying 1 meter per second squared, if you break down those units, it's 1 meter per second, right? 1 meter per second per second. So I'm changing my velocity by 1 meter per second every second. So if I start at rest, that means in the next second I'm going 1 meter per second. The second I'm going 2 meters per second, etc. If I'm already moving 100 meters per second, then I'm going to be going 101, 102, 103. So every second I'm changing my speed by 1 meter per second. You can have the same acceleration even if you have very different speeds. So if you're starting at rest and I have a negative acceleration, well, that means my next second I'm going -1 meter per second. And the second after that, I'm going -2 meters per second. But remember, negatives only tell you direction. So that just means I'm going 1 meter per second in the negative direction. I'm going 2 meters per second in the negative direction. So you're just going to the left, or you're going down instead of up. Okay? If you have a negative acceleration and you're moving in the negative direction already, so let's say you're going -10 meters per second, well, then you're going to have -11, -12, -13. So you're going to be increasing your speed in the negative direction by 1 meter per second. So it's a very interesting connotation. If you start at 10 meters per second in the positive direction, then this is going to slow you down because you're going to take away 1 meter per second every second. So then you're going to be going 9, 8, 7, 6, like that. In this class, we only have constant accelerations. In order to deal with changing accelerations, you have to be in calculus. So whenever they talk about constant acceleration, that's not the same as constant speed. It just means that whatever acceleration you're talking about, it's always the same value for that interval. So keep that in mind as well.